Okay, in this video, we're going to look at contrast coding and categorical variables in regression. Just as a note, if you start watching something with the same title from me in YouTube and it looks suspiciously like dummy variables, it is. I don't know how to delete things from YouTube, so there is that error. I put it in the comment. Also note, in response to a question I just got, I'm showing you coding and I'm showing it to you in linear regression. Well, your current assignment, of course, is logistic regression, but it's the same. I mean, how you code the predictors isn't different in linear regression versus in linear regression versus in logistic regression. What changes is the DV. And in linear regression, of course, you're predicting a score, and in logistic regression, you're predicting a probability. But the purpose of these little instructional videos is to talk about how to code, and I'm choosing to do it in linear regression because that's the more general case. Anyway, so we really truly are looking at contrast coding now. I hope the other one didn't cause you confusion. It's the same variable we've been using, and you've seen the other video. And so we start with, and again, this is linear regression. We start looking at did not drink versus the bought, stole, given alcohol. So we could say, can I predict a difference in number of drinks in one sitting between those who didn't drink and those who bought, stole, and were given alcohol? And then our second orthogonal comparison is a little more interesting, at least to me. And it's saying, can I predict number of drinks in a setting between those who bought, took, and stole versus those who were given alcohol? Now we have this. We've talked about the logic. We can go to SPSS. I actually wrote over the other file, so this is like the 14th time I've done this, but it's okay. I'm learning as you're learning. So we want to transform, recode the Q46 variable, this alcohol variable, which we have right here. Let me scroll up here. And we want to recode that into our two comparisons. So I'm hoping that you have those next to you, because really, I know I've said this about a bazillion times, but it's really hard to do this in your head, no matter how simple it appears to be, particularly when you're learning. So we begin by recoding to different variables, and I'm going to reset this so we can start from the beginning. And here we go. So our first variable, we want to recode our first contrast coefficient. We want to look at did not drink versus bought, stole, took, and given. So didn't drink versus got alcohol someplace. And so we did not, you have to underscore it, can't leave spaces here, did not drink versus drink. And a little longer thing, didn't drink versus got alcohol. And maybe that's a nice way to go. And we click on change, and we've got the old and new values. And so think this through, and I'll go slowly or extra slowly so you can anticipate. The first value, remember these are the old values here of the original variables, and here are the values you're putting in for the new variable. So if they were called at 1, that meant they didn't drink in the last 30 days. So for our first comparison, what's it going to be? What's our coefficient going to be? Well, if you're looking at the Excel printout, it's 2. The second variable originally was coded 2, and the new value, well, that's the bought, stole, and took. We want to compare that to the did not drink, so that'll be -1. And then the given was coded 3 initially in the original variable, and we want to code that -1. So we've got 2, -1, -1. Remember, from the logic little video, you could really code this anything provided it summed to 0, but I like whole numbers. It seems to work. So we pop that in there. Okay, and then I always check. There's no harm in just seeing that something's there that looks quasi-reasonable, at least to begin with. Then we do another one. Transform different variables. And now we want to compare people who bought, stole, or took it versus those who are given alcohol. We could just call this got versus given. And I might put on this contrast code. I didn't put on the other one, but it's good to be consistent. Got alcohol versus given. We're going to take one extra step on this that we didn't on the dummy code, just to make it crystal clear. It's amazing how easy it is to forget these codes. Whoops, legal character. Oh, I bet you can't put in the parentheses. Darn. Let's try. Okay, variable name. Got versus given. Oh, that's mad at us. Let's try again. Got underscore versus underscore. That should work. Good, perfect. See how it changes? And again, I am going to take out each one just to be crystal clear. So think it through. The first value was didn't drink. Remember this comparison, we're comparing people who were given alcohol versus those who bought, stole, and took alcohol. So this first group were the people who didn't drink. Well, they're irrelevant in this comparison. We're going to code them 0. The second group, the one coded 2, these are the people who bought, stole, and took. Well, we're interested in them in this, so let's code them 1. And then the third group is those who are given alcohol. So let's code them -1. And we click OK. And we are reassured that this is here. Now, one extra step here. This coding is arbitrary. And so what's easy to forget, even though you think you may never forget, is in a week or so, you'll think, well, what did I code high and what did I code low? It's really worth it to go the extra step here and what? It's going to take maybe 30 seconds tops and put in. So on this first variable, this is they didn't drink versus they got alcohol somehow. 2, well, what was 2? Well, we coded that didn't drink in last 30 days. You know, when you're in a hurry and you're doing a research project, it's easy to want to skip over these steps, but I think it really pays off in the end. Well, what do we code -1? And this is this variable here. What do we code -1? Well, they somehow got it. They bought it, stole it, took it, or were given it. So I've got a nice label. And then let's do the same here for they got it versus given it. So 1 was they bought it, stole it, took it. Bought, stole, took. And -1 is they were given. This helps down the line. So we have that done. We can go into regression. And actually, before I do that, I would double check. I run a bazillion of these because I keep making either little errors with the software or who knows what. So at one point I did screw up in this part, even while I was telling people to be careful. So I would look at this, look at the 2 new variables along with this, the original, and just checking. So here, this is the original, 170. And here we want to compare didn't drink versus got alcohol. Well, thank goodness we have 170 here. And we have 75 who bought, stole, or took, which actually works well because that's 42 plus 33. Then the got alcohol versus given, well, 170 we're not considering, coded them 0. And we've got 33 that were given and 42 that bought, stole, or took, which matches. So we are good to go. Thank goodness. It pays to just do all that double checking because nothing is worse than getting to the end of the analysis and going, shoot, I made a mistake in the coding. So let's go to linear regression. One more time, I'm showing you this in linear regression for this current assignment. binary logistic regression, the idea of coding doesn't matter. I'm just showing it this way to be a little more broad. So we've got question 44, and here's our did not drink and our got versus given. And again, experiment like crazy. And so we've got the output and from regression. And remember, we're predicting 5 or more drinks in a row. So this is a linear regression. And, I'm not going to interpret it because I want you to have the opportunity to practice. But indeed, you can predict how many times children have had 5 or more drinks in a row, given where their source of alcohol was. The constant doesn't have that nice interpretation that it does in dummy coding. This is a function of the grand mean here, not quite the grand mean, a function of the grand mean. Again, the coefficients, they're part of the difference between means, although typically they're not the difference between means. And we'll talk more about that later on in the quarter. So I think this is there. I'm going to let you interpret this as well for practice. I think this one, of course, if it had this one not been significant, we would have been really concerned that something was wrong. And I think this is kind of interesting, the second one. So what we've done in this video is we took our contrast coding and then we moved to SPSS and we recoded, we transformed into new variables or recoded into new variables, and then we ran a linear regression. So with that, there is all the logic for dummy coding and contrast coding with SPSS output, and all done in linear regression. And I'll let you, apply it to logistic, which is the same, except you're predicting a probability. As always, keep me posted on what's working and what isn't, and what kinds of videos you'd like to see. So have fun and experiment.